a week ago, we kind of woke up on Saturday morning to hear the unfolding story of this earthquake in Kathmandu. And what I thought I'd do a week on was just kind of take stock and go to a few web pages and try to bring the story together to think, 7 days in, what do we know and what's the prospect for the future? And one of the obvious questions that first of all comes up right at the start is why do you get an earthquake? Why have we got earthquakes in this region? And this site by Jean-Philippe Avouac, it's a Caltech site, but he's now at Cambridge, just overviews the area. And he's got this diagram here which shows you how this zone of what's called beach balls, forget about that, these are earthquakes that occur in this area here. This is India, and India is moving northwards towards Asia at about 48 millimetres a year, 50 millimetres a year. So about 5 centimetres a year, India is moving northwards and actually underneath Asia. You get a sense of that from this one here. This is a vertical slice from India northwards through Kathmandu to Tibet. And you can see the depth of 0, 10, 20 kilometres. And this line, this black line, is the fault line. It's a thrust, it's a low angle thrust, because what's happening is that Asia and Tibet and Nepal is getting thrust up as India gets pushed down underneath them. And although to the north there's a lot of deep earthquakes, the point is that underneath Tibet we've got the fault line is very shallow and very low angle. So any earthquakes that we get on there, the energy gets translated very quickly to the surface and you get strong shaking. This fault line, it's referred to as a blind fault because it doesn't appear at the surface. But this fault line essentially underlies almost all of Nepal. That's the problem. In that area, the biggest earthquake we've had in kind of recent history was an earthquake, the Bihar earthquake in 1934. Now that was a big earthquake. That was a great earthquake, bigger than an 8. The earthquake of this week was a 7.8. There's various other sites that we can look at in terms of getting some information. So one of them that's quite useful is the CEDIM Forensic Disaster Analysis site that was put out a few days into it, with lots and lots of facts and figures and metrics about the hazard, about the vulnerability, about the aftershock activity, how the aftershocks decay over time. So in the day afterward it was a magnitude 6.7, but in the days afterwards they tend to drop away in magnitude. But they still can rattle and rock the place for days and even some weeks. So that's quite useful. There's a site called Earthquakes Without Frontiers, which is a UK-led research group into earthquakes from Leeds University, Cambridge, Oxford, Durham. And they're looking both in terms of the earthquake science, but also how to keep people safe and also to the effects of landslides. Quite a few of the images that I'm going to show really come from that site. But in terms of what we know about it, we've got some information in the last few days really from Sentinel, which is a new satellite by the European Space Agency that's up there. And it takes radar images, takes pairs of images, and builds a kind of map of the elevation changes. So what it does is compares an image from before with an image afterwards, and basically sees what is the elevation change. And so you end up getting these rather colourful images called interferograms. And basically you'll see this kind of colour. This is the India, this area of kind of purpley yellow out here. There's a plate boundary, and then this is the area of Kathmandu and in Nepal in the Himalayas. It's probably easier to see it up here. Each of these zones of colour, these corridors of colour, are called fringes. And they represent 2.8 centimetres of vertical change. Very, very detailed. What you see is India, small amounts of elevation change, but then you concentrate, it's all concentrated in here. In fact, if we go and zoom in on this, what we see is here are the fringes that are quite broad out in India, but really closely spaced when you get into Kathmandu, and you can see the main zone of the deformation coming through here. This is those fringes, that interferogram draped onto a Google image. And you can see India here with not too much happening. There's been deaths reported from northern India, but not too much in terms of elevation change. And not too much in Tibet, but all of it getting really concentrated in this area of the Kathmandu Valley. So putting it all together, this is an image that came out of the COMET team, which is a team led by Tim Wright at Leeds, where they're using space images, space measurements to look at earthquakes. And you can see that the colours on here, if it's the red colours, that is subsidence. If it's really strong red, it's up to 2 metres. Any of the blues, particularly dark blues, has risen up. So what you can see is that during the earthquake, the area of Kathmandu and Kathmandu Valley went up, and the area of the Himalayas to the north dropped down. And that's pretty representative of what we expect from these kind of faults. As they move, some areas get pushed up, and other areas get flexed down. The key thing isn't the elevation change so much, it's the actual shaking. It's the shaking that kills lives, because it's shaking that brings down buildings. And this is a map of fatalities. What we see is the epicenter across here in Gorkha. This has been called the Gorkha earthquake. And but we see actually not that many casualties in Gorkha province. The main casualties are in Kathmandu, where much of the population is kind of pressed in, and these upland areas further to the north. And there's a lot of attention also on Mount Everest across here, because Westerners are there. Sometimes I've seen quite a lot of criticism of the news footage, because they're saying, well, look, actually, it's only a fraction of the deaths that's out in Mount Everest, and yet something like a quarter, maybe 23% of the news coverage is about Everest. On the other hand, it's the sheer presence of Westerners probably that's kept this event in the news and kept people, giving money in for that relief effort. So this is a trade-off that's quite, it's quite difficult to balance. However, one of the things that we see is that the death toll seems to be concentrated in this area, but that's a little bit misleading, because that's the area that the media and the relief efforts have managed to get to. Over the next few days and weeks, we're starting to get out into these other areas, and what is starting to appear is a much higher death toll. In fact, I was looking at a site. This is one site from BBC News today, talking about as you go further afield into central Nepal and upland Nepal, devastation becomes total. You can have whole villages just gone. So it is very likely that this death toll of today, 6,500, will continue to rise. One estimate, which takes an estimate of the shaking, the estimate of the concentration of population, suggests that the death toll may get above 50,000. So we should kind of steel ourselves for this being much more substantial than just simply 6,500, even though that would be bad. One of the points is that people have kind of commented, well, actually, why is there not more fatalities and damage near the epicenter? Many earthquakes, we have the epicenter be the center, and the energy radiates out in all directions, so the strongest shaking is right beside the epicenter. But in a sizable amount of earthquakes, you have the epicenter at one end of the fault line, and it rips along the fault, and as it goes through, by directing those energy efforts, it increases shaking. So you end up with the highest shaking not been at the epicenter at all, but actually been concentrated at the other end. And that's pretty much what we see. This is a US Geological Survey map that models the earthquake and shaking. This rectangle is what we think is the buried fault, essentially, that is ruptured. There is the epicenter, and it's ruptured in this direction, heading east, shaking all of this area here. This image really shows what we see around Kathmandu. Classic image, really, of buildings, multi-storey building, built with brick and mortar. What we see is the buildings just haven't withstood the shaking, and it crumples down. And of course, that weight of material is what kills people in the rubble. You can see at the back buildings that have been built with reinforced concrete, and they've stood up. And so I think one of the things that we're seeing is that magnitude 7.8 has actually meant that it's picked out the really weak, older, infirm buildings. Anything bigger than an 8, certainly to an 8.5, would have brought down those concrete buildings as well, and that would have been a step change in the fatality toll. So this was when I flew into Nepal a few years ago and flying into Kathmandu. And what you see is just this is a suburbs, just way in the outskirts, and you just see this huge increase in modern apartment blocks that's been formed just probably in the last few decades. You get a sense of the scale of Kathmandu. And one of the critical things really has been how they've fared in the earthquake, and it seems like they've fared pretty well. One of the worries was that these kind of modern concrete ones, with lots of people crammed into, might collapse and fail, pancake down, and the death toll will be huge. But that doesn't seem to be the thing that's happened. But you get a sense here of just how jam-packed everything is as I was just coming into the airport now. The oldest buildings fared pretty well. This is a 1,500-year-old temple. It's gone through loads and loads of earthquakes, and it's comparatively undamaged. And so what we see is the old buildings that have been tried and tested, if you like, withstand it. The brand new ones that have been fitted to protect earthquakes are good. And the problem ones are the ones in the middle. And a lot of the buildings here were buildings that were built 50, 60 years ago. Many of them actually built after the 1934 earthquake. Used the rubble of 34 to rebuild. Of course, they've just come back down again. This is a school that was destroyed in the earthquake. But of course, the earthquake struck on a Saturday, so there was no one in school. If this earthquake had struck 24 hours earlier, or indeed on Monday or the Tuesday when schools were occupied, the death toll amongst young people, amongst children, would have been really high. So one of the saving graces really this week is that it hit on that Saturday. Something like 10,000 schools in Kathmandu Valley, of which 250, 260 have been built to withstand earthquakes. And that's one of the things that we're going to have to address looking ahead. The problem is, as we go out into the provinces, into the upland areas, and the images are just starting to come through now. This is one just an area to the north, and you see almost every building is down. It looks like a modern one in there that's not, but these buildings have just crumpled. Just stone and brick held together with bits of mortar, even maybe some daub and wattle, the kind of mud brick in there. Some of them with quite thick, heavy roofs of tiles, and all that comes down, and that's a lethal combination. You know, this is the adage that earthquakes don't kill people, buildings kill people. We should be able to build buildings better than this. The sheer scale of this you can see when you go into the air. Almost all of the buildings in that village have been destroyed, and that would have a really high casualty rate. One of the other fears really in this thing is landslides, and there's a really good site that's for a lot of the information. It's called Landslide Blog, which is one by Dave Petley, which is one of the Earthquake Without Frontiers workers. Dave's an expert on landslides and hazards, and puts together a fantastic site. Really, with the information coming on, today's been asking on Twitter for information about, from YouTube videos or photographs, about the landslide to try and map out where the biggest risk is, and extraordinary images coming through of these provinces. The problem with landslides is that not only can it take out a whole village on its own, a landslide, but also a landslide can dam a valley. It can cause a river to bank up and produce a lake, which then can breach and cause flooding downstream. So in many cases, the earthquake is just the start of a whole contagion, a whole chain reaction of problems. One of the questions that's going to come out of this undoubtedly is what happens next, and is there another big one? And this is an interesting point, because this is an area that certainly geologists have been saying for about 20 years or so have had a chance of an earthquake. Well, this is a map put together by Roger Billamit in Colorado, and what you see is this is India with its earthquakes, this is the plate boundary, and this is a representation of the possible magnitude. So this is based on the idea that this movement of India, we know how much strain is gradually building up, and we know how much has been released in recent earthquakes. So if there's been earthquakes that's not been big enough to release strain, we know that they're sitting, lurking, waiting there. So some areas have got relatively modest earthquakes because they've already had earthquakes to release some of the pressure. But in Kathmandu area, we've got these two columns here, whereby this has been predicting or been forecasting as certain that we would have to have a magnitude 8 earthquake to release the rest of the strain. But it could be anything up to 8.2 or 8.3. Now clearly we've had a magnitude 7.8. So one of the big questions for the earthquake science community is how much of this strain has been taken up and how much is still there? Could we still have a great earthquake of magnitude 8 plus? And many people think we could. But really I would say that is a thing that is now for the discussion point for weeks and months ahead. You know, I think it's we have to be very careful that the climate of fear that exists in Kathmandu and Nepal right now about aftershocks and about that, we don't add to it by the suggestion there is an even bigger earthquake waiting to happen. So we need to be very careful not getting too carried away. But this is the worry for geologists, is that we know this, we've known this for 20 odd years, that this is the situation. So what else can we do? Well, I mean, clearly one of the things is providing money for the recovery efforts. Today was highlighted as the last day. There's not any expectation of finding any more people alive in the rubble, so it's now a recovery operation and rebuilding, etc. But in doing that, lots of disaster specialists coming out and saying, look, this just isn't a case of rebuilding better. We should absolutely do that. We should learn from the mistakes of the past. But also it's about education. It's about building resilience within the communities themselves. It's about local communities being given the information for their own safety and developing safer practices about how to live in what is essentially earthquake country. So this is a window of opportunity by which scientists can work together with authorities to start thinking about how we build resilience into the system. As ever with one of these events, it is a revelation about what the earthquake can do. But unfortunately, for most people who work in earthquakes, what we've seen in the Nepalese earthquake is what we've seen in most of them, which is that we have that very clear knowledge of the earthquake science. We know where the danger areas are, but we just can't seem to connect to be telling these local authorities and the people there about what to expect. I read a quote from an interior minister earlier this week saying they had no idea that it was going to be this big. Well, geologists have been arguing it's going to be even bigger. It could have been even bigger. It could have been worse. I'd say an earthquake bigger than that, magnitude 8, could have brought down a lot of those modern constructions where a lot of the population lived, and death toll would just have been unfathomable. So I think that this idea, we got to start being able to learn how we can communicate what we know about earthquakes.